Now that we've had a look at what a solution is and defined a couple of terms behind solutions, the next thing we need to look at is how we can measure solutions, and the term that we use most often is concentration. So concentration of a solution is a measurement of how much solute is dissolved in a solvent using things like ppm, that means parts per million, G per liter, grams per liter, or percentages. Remember, any percent just means a part per a total. Looking back at that definition, remember that the solute is the material that gets dissolved, whereas the solvent is the thing that does the dissolving. So in Kool-Aid, the solute might be sugar, whereas the solvent would be water. The most common units of concentration that we use in chemistry, however, are moles per liter, which is what a molar is defined as. If you see the abbreviation capital M, that actually means moles per liter. Molarity is defined as the moles of solute per liter of solution. Notice that that solution is the final mixture. So to make, for example, a 1 molar solution of sodium chloride, it has to contain 1 mole of sodium chloride in 1 liter of that final solution, that final mixture. 1 mole has a mass of 58.44 grams for sodium chloride. That's its molar mass. And in order to prepare that final solution, I'm going to add water to make 1 liter of final solution. So the question then becomes, well, for example, how could you make up a 2-liter solution of 0.25 molar sodium chloride? The first thing we need to do is find the moles of sodium chloride we need. And that connection is that molarity, capital M, equals the moles per volume. I know that my final solution is 0.25 molar. My moles is what I don't know, and my volume is 2 liters. So now doing some algebra, the moles are 0.5. That means I need half a mole in order to produce that solution. Now, you already know, though, that moles are really an intermediate unit. It doesn't actually mean a whole lot for us. So instead, we probably need to change those moles into grams. For sodium chloride, we always start with the number that we're given, or the number with a single unit. So I know I have 0.5 moles that I need. To change my unit, I draw an X and a line, and the mole unit goes on the bottom. Always until today, we put a 1 in front of the mole, and the gram unit goes on the top. That's what I'm trying to get to. We already said that the molar mass of sodium chloride is 58.44 grams for 1 mole. So half of that works out to 29.22 grams. That's how much mass of sodium chloride I need to use in preparing the solution. And I want 2 liters of solution. Notice again, it's 2 liters of solution, not 2 liters of water. So in order to make that solution, I need to add the 29.22 grams of sodium chloride to a container, and then add just enough water to make 2 liters of solution, of final mixture. I'm not adding 2 liters of water. Now, the second thing we have to look at when we do calculations is that we can actually do dilution. So if you have a solution that's already prepared, water can be added, or it can actually be evaporated off to change the concentration of the solution. Also, if I happen to mix 2 solutions together, the concentration of the molarity is going to change. When I add water, or whatever solvent it is, notice that my moles are staying the same. The moles of the solute are staying the same. It's only the volume or concentration that's changing. And this brings us to one of a couple of forms of a dilution formula. One form happens to look like this. This is what the textbook happens to use if you look at your Hebden. So the V old square brackets mean concentration or molarity equals the V new times the new concentration or molarity. The form that I happen to prefer, because I think it's easier to remember, is that M1V1 equals M2V2. And the reason for that is that M times V is equal to the moles. And I already know that the moles in my solute before and after aren't changing. So let's look at how to do this in a couple of practice calculations. So it asks us to find the new concentration when 2 liters of water are added to a 1 liter solution of a 3 molar sodium chloride solution. Notice that I've got 3 values here that I have to work with. I know that I'm going to use M1, V1, M2, and V2. So the question is, what of those values do I know first? Well, I know I'm adding 2 liters to produce a final solution. So I know that my final volume is 2 liters, but it's the 2 liters added to the 1 liter that I started with, so it's 3 liters. I also know that I had 1 liter to start with, and the concentration of that solution was 3 molar. A helpful little hint for you is that when you go to use the dilution formula, M1V1 equals M2V2, if you see the word of acts like glue. It actually means to multiply. So the 1 liter of the 3 molar, that cements those two numbers together. They have to be on the same side of the equal sign. So even if you don't know the 1s versus the 2s, which isn't really all that important, it is important that those two values end up on the same side of the equal sign together. So substituting in now and solving, so my 3 molar and 1 liter equals my M2 times my 3 liters. I have to do a little bit of algebra here, so I'm going to end up dividing both sides by 3 liters. And I get that my molarity, my second molarity, equals 1 molar. I've diluted the solution from 3 molar, 3 moles of solute per 1 liter, to 1 mole of solute per 1 liter. The next thing I want you to do is to try this practice question on your own, and then I'll give you the answer. So a student has 500 milliliters of a 0.4 molar solution of sodium chloride. How much water is needed to make this solution 1 molar? Quick thing for you here is that when we were doing our statements before, the volume was in liters. So I always want you to get in the habit of changing these milliliter values into liters. If the two volumes happen to be the same, you'll still have your answer work out, but ultimately some people will miss that step, and sometimes they're not compatible. So I would rather you get in the habit of always changing your values into liters. So we had 0.5 liters of a 0.4 molar solution, and how much water is needed to make the final concentration of 0.1 molar. Notice that this is how much water is needed. That's not what is the final volume. So V2 here is going to equal my 0.5 times the 0.4 divided by 0.1. I've just manipulated the formula doing some algebra, and that should work out to 2 liters. That's the final volume. And the final volume equals your initial volume plus the water you added. So if I want to know the water I added, if my final volume is 2 liters, and I started with 0.5 liters, then my water added was equal to 1.5 liters. Let's try another one. So a chemist adds water to 120 milliliters of a 6 molar solution of sodium hydroxide until the final volume is 2 liters. What's the molarity of the resulting solution? So see in this question how we've got milliliters and liters. So it is important, like I suggested before, to make that change so that everything is always in liters. So this happens to be 0.120 liters. Remember, there's 1,000 millis in a liter, or in a base unit. So I have 0.12 liters of solution of a 6 molar solution, to be more particular, and I know my final volume is equal to 2 liters. So doing the algebra means I need to divide both sides by 2 liters, and my M2 should equal 0.36 molar. So that's my final concentration. And that's actually where we're going to leave it. I realize that that's a short thing for you to do, but I don't want to overwhelm you with a whole bunch of new concepts. We're going to do some reinforcement work as soon as we get to class next day.